In this video, we're going to be looking to transform these exponential functions. Here is our new transformation form. Notice again the minus h here on the k would move your function either right or left. The plus k at the end would move it up and down. The a value here would stretch or compress it. Now notice it's not being multiplied by the h or to the x, so therefore this would stretch it or compress it vertically. So therefore, let's go over all this. H is the horizontal shift, and the reason again we know it's horizontal is because it's on the x value. A plus would shift it left as always, and a minus would shift it right. The k, the plus k on the end, is your vertical shift, and it does exactly what it says it will. The plus will shift it up, and the minus would shift it down. If a is a negative value, that's going to flip it vertically. The function is flipped. Looks very familiar across the x-axis. If a is greater than 1, that would be a vertical stretch. If a is less than 1 or between 1 and 0, that would be a vertical compression. So now let's go through and let's identify the parent function and describe the transformation. The only transformation on our first one would be this plus 5. Now the parent function, f of x equals, now this number right here is part of your parent function. Your parent function is y equals this number to the x power. Now from that parent function, the only thing that's going to happen is your graph is going to be shifted up 5 units. Number 2, your parent function. Take away the multiplication, take away the plus and minuses. The parent function is going to be 1/4 raised to the x power. Now let's go back and look at the transformations. We're going to look at stretches, compressions first. The 2 out front would be a vertical stretch by a factor of 2. And then the only other transformation is going to be this minus 1 on the x. If it's a minus 1, that's going to move your function right 1 unit. Minus right plus left. Next function, take away all the pluses, minuses, and negatives, and your parent function is going to be y equals 4/3 raised to the x power. Now your transformations here, let's do all stretches and compressions. There's not any, there's no multiplication. Any flips next, that negative right there is going to flip it up and down. It's going to flip it vertically, which would be across the x-axis. And then the last 2 transformations will be the translations. The plus 2 would move your graph left 2. The plus 7 would move your graph up 7. Number 4, parent function, y is equal to whatever number is being raised to the x power. Transformations, let's do over multiplication first. 1/2 is being multiplied. Since 1/2 is smaller than 1, that would be a vertical, again, it's not on the x value, so it's a vertical compression by a factor of 1/2. And then the only other 2 transformations are these translations. The minus 4 on x would move it right 4 units. The minus 2 on your y would move it down 2 units. Okay, number 5, it says graph each function and identify its key characteristics. Now before I graph this, I'm going to graph the parent function. The parent function of 2 to the x plus 5 would be just plain 2 to the x. Let's see what it remind you what it looks like. And there's your graph along with the points over here. Now we're going to take each of these points and we're simply going to move them all left 5. So therefore what used to be at -1 is now at -6. So moving it left 5 only changes your x value. It's going to subtract 5 from all of them. And then your y values will stay the same. 1/2, 1, 2, and 4. Now let's graph these new points and see what our new graph looks like. And you can see that you have the exact same graph, just been moved left 5. Your domain, again, you can plug in anything for your x. Your range, you have not moved it up or down any, so your range is still the same. As you travel to the right, your graph increases. As you travel to the left, your graph levels out to 0. Now your y-intercept has changed, and you can't tell here what your y-intercept is. However, if you remember correctly, to find your y-intercept, what you've got to do is plug in 0 for x. So my y-intercept will be 2 to the 0 plus 5 power, which again, just find f of 0. That's going to be 2 to the 5th power, which is 32. So your graph is going to cross at 0, 32. Your asymptote line is still in this graph the x-axis. Next problem. Let's go ahead and graph your parent function, and the parent function of this one would be y is equal to 1/3 to the x power. And there you see your graph. Let's go ahead and take the points and write them down. And that should be plenty. And the only transformation, you're going to take your parent function and move it down 2. So again, that only changes your y value. So all the x values stay the same and all the y values get decreased by 2. Now, something else to think about here, since you're lowering your graph by 2 units, you're also lowering your asymptote line. The asymptote line used to be this x-axis. However, now it's going to be y equals -2. You're going to move that line down to the horizontal line, y equals -2. That'll be your new asymptote line. So let's plot these points and see what our graph looks like. So there is our new function. Our domain has not changed. It still goes from left to right forever. However, our range has. Instead of 0 to infinity, we moved everything down to, it'll now be from -2 to infinity. As we travel to the right, now our graph levels off not to 0, but our y value levels off to -2. As we travel to the left, we do go to positive infinity. Our x-intercept also got moved down 2. You can either plug in 0 for x, or you can just say it used to be at 0, 1. It is now down 2 units at 0, -1. And again, our asymptote line, which used to be y equals 0, got shifted down 2 units to y equals -2. Next problem, let's graph first off our parent function, which for this one would be y equals 3 to the x power. And there it is along with your 4 of your points on your graph. Let's identify the 2 transformations, and here they are. Our first one, always do your multiplication first. So we're going to multiply by 1/2. This is going to be a vertical stretch, or excuse me, compression, because it's less than 1, a vertical compression by a factor of 1/2. And that's going to be our first transformation. And then our next transformation, we're just going to simply move our graph up 1. So there's our 2. And again, y compression by 1/2. Notice all the x values will stay the same. We're only going to multiply our y values by 1/2. So let's do that first. And then we're going to take all of our y values and just move them up 1 unit. So add 1 to all the y's. And you can see here the new graph, and notice again your asymptote line got moved up this 1 unit. The stretch didn't affect it at all because it was at y equals 0, but then it got moved up 1 unit. Our domain would still be everything. You can plug in anything you want. Our range values now start at 0, and they go up from there. In behavior, as you go to the right, your graph goes up. As you go to the left, my y value now levels out at 1. Your y-intercept is now right here, and used to be at 0, 1, and that got turned into 0, 1.5. So you can just look at that dot to see where it got moved to. So there's your y-intercept now. Your asymptote line again is now y equals 1 instead of y equals 0. Next problem. Your parent function again is going to be at f of x, or y equals the 3/2 raised to the x power. So let's take and plot those points and see what that graph looks like. Okay, and there's your graph. And I just took 3 points, and we'll just transform these and see what happens, see what they now look like. There's only 2 transformations, here and here. We're going to take each of our points, we're going to move them right 4, because the -4 on the x, and then we're going to move them down 5. So we'll add 4 to the x's and subtract 5 from the y's, and now here's what you get. And there you see the new points in the new graph. And again, your asymptote line, we can do it first. Since everything got moved down 5 units, then so did your asymptote line. What used to be at y equals 0 is now at y equals -5. Your domain is still all real numbers. Your range now starts at that -5, the asymptote line, and goes up. As you travel to the right on your graph goes up. As you travel to the left, your y value approaches that asymptote line at -5. And your y-intercept, can't really tell what it is there now. So what we're going to do, we're going to take your graph, and we're going to find f of 0. We're plugging in 0 for x. That's how you find your y-intercept. That's going to be 3/2 to the 0 minus 4, which is -4 power minus 5. When you clean it up, a fraction raised to a negative, we'll flip it. That'd be 2/3 to the 4th minus 5. To do 2/3 to the 4th, we can actually raise the top and the bottom to the 4th power. That's going to be a 16 over 81 minus 5. We can type that into our calculator and give ourselves a decimal answer, or we can find us a common denominator. That'd be 16 over 81 minus, multiply top and bottom by 81 would be 405 over 81. 16 minus 405 gives us negative 389 over 81. So that's going to be our y-intercept, 0, comma, negative 389 over 81. And you might be able to reduce that, or you could change it to a decimal answer. That's going to be somewhere around 1, 2, 3, 4, about 4.8 or 4.9. Okay, the last problem. Let's first off graph our parent function, which will be y equals 4 to the x here. So let's plot those points and graph it. Okay, so there's our graph, and there's some points that are on our parent function. Now let's identify, there's 3 different transformations. Let's identify those transformations, and let's transform these points. First off, our stretch. This will be a vertical stretch, which again, I like to just call it a y stretch because the y would be the vertical. And that's going to be times a factor of 2. So we're going to multiply all of our y's by 2. You have a negative out front, so that's going to be a vertical flip. And that flip will carry it across the x-axis. So again, all that's going to do is our y value will change from a negative to positive or positive to negative. And then my last transformation, I'm going to move all my points to the right 2 because of this minus 2 on the x. So let's perform those transformations. We'll do the first one, the y stretch first. And there's all my new points. Now, to flip it across the x-axis, again, all that's going to do is make our y values from a negative to a positive or positive to negative. So if you'd like to, you could just go through here and just change all the positives to negatives and all the negatives to positive. And then we're going to move it to the right 2, which changes our x value. So all my x values, I'm going to add 2 to the x values, and here's what you're going to get. Okay, so I've performed all the transformations, graphed my points. Here's my new graph, my domain for my new graph. Again, I can plug in anything into an exponential function I want. However, in this case, I only get values from negative infinity up to that same horizontal asymptote remains here, 0, because I flipped my graph, I stretched it, which didn't change anything, then I moved it left or right 2 units. So that did not change my asymptote line. So it will still be located at y equals 0. My end behavior, as I go to the right, my graph decreases. As I go to the left, my graph levels out to 0. My y-intercept was just located right in here. In order to find that, we're going to plug in 0 for all of our x's. And let's see what we get. We have negative 2 times 4 to the negative 2 power, which would be negative 2 times 1/16, which is negative 1/8. So that's going to be my y-intercept is going to be located at 0, comma, negative 1/8.